Good morning everyone. Welcome back to PRS Chemistry Classes. In the last sessions we have completed the Daniell cell, that is construction and working. In today's session we will discuss about the electrode potential. So before going to discuss about this electrode potentials, let's have a look on the last concept, that is construction and working of Daniell cell. The Daniell cell consists of two compartments. In one case, zinc is dipped in zinc sulfate solution, whereas in the second compartment or the second vessel or beaker, the copper electrode is dipped in copper sulfate solution, and these two beakers or vessels or compartments, these are connected by means of salt beds and conducting wires. So these two beakers are, we can call as half cells or simply redox reaction, because in one case oxidation reaction taking place and in the other case reduction reaction taking place. Look at this. The beaker are the half cell in which oxidation reaction taking place. The half cell in which oxidation reactions takes place is known as anode, which is negatively charged terminal. The half cell in which oxidation reaction takes place is known as anode, and the beaker or the cell or the vessel or the compartment in which reduction reaction takes place is known as cathode, and which is positively charged. Here flow of electron takes place from one electrode to the another electrode, that is from zinc electrode to copper electrode, and by conventions the flow of current is considered in the opposite direction. तो ये concepts हमको पता है. Now what is meant by electrode potential? Why the electron flows from zinc electrode to copper? Why not from copper to zinc? इसके बारे में थोड़ा स्टडी करेंगे. Now electrode potential. In order to understand this electrode potential, let us consider a half cell. We will considering one half cell. So this is one half cell I have considered in three different cases. In first case, it is a metal. यहाँ पर आप कौन से भी metal ले सकते हैं. So I have taken a zinc metal, that is zinc electrode. Zinc electrode dipped in zinc sulfate solution. Zinc sulfate solution. This is electrolytic solution. So in this electrolytic solution, Zn2 plus ions are present in the solution, and it is metal electrode है यहाँ पर. This is zinc electrode dipped in zinc sulfate solution or its solution, its electrolytic solution. Solution में Zn2 plus ions are present and the metal is dipped in it. Now when an electrode is dipped in the electrolytic solutions, so here there is three possibilities. What is that? The metal atom of the electrode, which may have a tendency to go into the solution and trying to make it as a negative terminal, negative charge. So आपको ये पता है, अगर ये जो atom है, the atom from the zinc electrode, when it goes into the solution, this electrode getting the negative charge. How it getting the negative charge? तो आप यहाँ पर देखिए, यहाँ पर if the zinc atom from the electrode which goes into the solution, that means which undergoing oxidation, that is it dissolves. When it dissolves in the solution, Zn2 plus ion which enter into the solution, यहाँ से Zn2 plus ions यहाँ पर आ गया. So when Zn2 plus ion enter into the solution, two electrons which remains on the electrode, ये जो है this Zn2 plus ion, when it enter into the solution, two electrons remains on the electrodes, thereby it getting the negative charge. यहाँ पर negative charge आ रहा है. If the electrode have a tendency to undergo oxidation का tendency रहा तो that means losing of electrons, it getting the negative charge because electron remains on this. And the second tendency, if the metal ions have a tendency to get deposit on the electrode and trying it to make as positive, So So this occurs in case of copper electrode. Copper electrode में ऐसा है, suppose यही है zinc assume करो. If zinc has tendency to gain the electrons, ये तो नहीं यहाँ पर zinc undergoing oxidation, ये कॉपर के केस में होते हैं यहाँ पर. मतलब सपोज यहाँ पर कौन से भी मेटल बोल के कंसिडर किया है हमने. इफ दिस इलेक्ट्रोड, इन दिस इलेक्ट्रोड ions have a tendency to get deposit on this, that means Zn2 plus यहाँ पर ions है, these ions have a tendency to get a deposit on this. डिपॉजिट हुआ तो सॉलिड फॉर्म हो जाएगा, सॉलिड फॉर्म होते हैं. ये ऑक्सीडेशन हुआ तो ऐसा है, एंड इट इज रिडक्शन. दैट मीन्स इन दिस केस ये जो +2 आयन से इसके ऊपर आके डिपॉजिट हो रहे, देयर बाय दिस इलेक्ट्रोड गेटिंग ए पॉजिटिव चार्ज सराउंडिंग ऑन इट. तो इसके ऊपर पॉजिटिव चार्ज आ गया, पॉजिटिव चार्ज. सो दिस चार्ज बिकम्स पॉजिटिव टर्मिनल. सो राइट नाउ वी हैव डिस्कस्ड the reaction vessel or the half cell in which oxidation takes place is known as anode and which is negatively charged terminal. Anode बोलते इसको. Anode के केस में, in case of anode oxidation occur, ये oxidation का reaction है. That means electrode dissolves in the solution, concentration of Zn2 plus ion increases, it getting negative charge. In the other case, if the electrode have a tendency to undergo reduction, reduction हुआ तो Zn2 plus का constant, not only यहाँ पर तो यहाँ नहीं होते, यहाँ पर this zinc have a tendency to undergo oxidation. In this case, if you are considering copper, it has a tendency to undergo reduction. Copper का tendency reduction होने का. But suppose now we have considered zinc. Let us take this as an example. अगर ये रिडक्शन हुआ तो जिंक गेट डिपॉजिट एंड इट गेटिंग द चार्ज पॉजिटिव. रिडक्शन हो रहे, इसलिए इसको हम क्या बोल रहे, कैथोड. द हाफ सेल इन विच रिडक्शन रिएक्शन टेक्स प्लेस इज नोन एज कैथोड विच इज पॉजिटिवली चार्ज टर्मिनल. इन जनरल ये जिंक की जगह हम पर्टिकुलरली मेटल यूज कर सकते हैं. सो देयर इज 3 पॉसिबिलिटीज एट इक्विलिब्रियम. इन दिस केस एज देखो यहाँ पर एट द पॉइंट ऑफ इक्विलिब्रियम there is a separation of charges. Equilibrium point means there is a separation of charges between electrode and electrolyte. At the interface of this electrode and electrolytic solution, charge separations हो रहे हैं यहाँ पर. Either that is due to the tendency to undergo oxidation or reduction. हमको पता नहीं कौन से भी एक electrode लेके solution में dip किया तो either it undergo oxidation or reduction. That we don't know whether it undergoing oxidation or reduction. So in order to find out the electrode potential means ये जो tendency है, the tendency to undergo oxidation or reduction is known as electrode potential. This is the definition and it is a concept. So let us look at the definition. Electrode potential is defined as it is a tendency of an electrode to get oxidized or reduced is called as electrode potential. Or simply we can say at the point of equilibrium, there is a separation of charges between electrode and its solution. This develops a potential difference. The potential difference develops between the electrode and the electrolyte is known as electrode potential. This is a simple term. And if the concentration of this electrolytic solution is 1 molar, concentration is 1 molar, the concentration of all the species involved in the half cell reaction is 1 molar, then this electrode potential is known as standard electrode potential. What is that? Standard electrode potential का definition क्या है? If the concentration of all the species involved in the half cell is unity, then the electrode potential is known as standard electrode potential. Standard electrode potential. And here the metal or the electrode which is dipped in the electrolytic solutions, either it has a tendency to undergo oxidation or tendency to undergo reduction. So based upon that, oxidation potential and we are calling reduction potential. What is meant by oxidation potential? Tendency of an electrode to get oxidized is called as oxidation potential, or else tendency of an electrode to get reduced is called as reduction potential. ये इसका 2 definition हुआ, oxidation potential and reduction potential. So based upon this ये कॉन्सेप्ट क्या हुआ? इट इज अबाउट इलेक्ट्रोड पोटेंशियल डेफिनेशन एंड कॉन्सेप्ट। ये एक हुआ। नाउ इन द डेनियल सेल, अगर हम बात करते हैं कि डेनियल सेल का, इन द डेनियल सेल द सेल पोटेंशियल इज फाउंड टू बी 1.1 वोल्ट, राइट? डेनियल सेल में इलेक्ट्रोड सेल पोटेंशियल ऑफ ए डेनियल सेल इज 1.1 वोल्ट। व्हाट इज दिस सेल पोटेंशियल? ये सेल पोटेंशियल क्या है? दिस इज in with respect to the half cell we are calling as a electrode potential, but in this case we have taken two electrodes. Electrode potential of zinc or zinc electrode potential and copper electrode potential दोनों different है। so ये दोनों different है। when these two are connected with each other, then the potential difference between these two electrode is known as cell potential. So the next definition is cell potential of a cell, or we can call it EMF of a cell, electromotive force. So here, when two half cells are connected with each other, in this case, दोनों का जो potential tendency to undergo oxidation and reduction potential जो है, tendencies जो है, that is those having different tendencies. So this difference, the potential difference set up between two electrodes of a cell is known as cell potential of a cell, or simply EMF of the cell. And this can be given by cell potential of a cell is given by reduction potential of cathode minus reduction potential of anode. Here you can note the one point. In case of standard electrode potential, ये जो standard electrode potential है, according to IUPAC convention, IUPAC convention, all the electrode potential, standard electrode potential is expressed as standard reduction potential. According to IUPAC convention, the standard reduction potentials are now called as standard electrode potential. Standard reduction potential को ही standard electrode potentials बोल रहे हम now. That means suppose if an electrode having a tendency to undergo oxidation, that is SOP, standard oxidation potential जो है, इसको भी हम SRP में ही represent करते हैं by using standard reduction potential by changing its sign. अगर ये पॉजिटिव है तो उसको नेगेटिव कन्वर्ट करके रिडक्शन पोटेंशियल में बोले. दिस SRP is nothing but standard electrode potential. तो यहाँ पर cell potential of a cell is nothing but reduction potential of cathode minus reduction potential of anode, and this can be written as E cell is equals to E right minus E left. or simply यहाँ पर देखिए, at the right hand side, at right side of the cell reduction reaction is taking place. reduction reaction, ये cathode है, so simply E cathode, the electrode potential of E cathode minus E anode. एनोड मीन्स वेयर ऑक्सीडेशन अकर, ऑक्सीडेशन हो रहे यहाँ पर, वो ऑक्सीडेशन हुआ तो भी उसको हम रिडक्शन पोटेंशियल में लेना चाहिए, कंपल्सरी रिडक्शन. ई रिडक्शन पोटेंशियल एट द राइट साइड माइनस रिडक्शन पोटेंशियल एट द लेफ्ट साइड, ये ई सेल. दिस इज द बेसिक फार्मूला है. ई सेल इज इक्वल्स टू ई राइट माइनस ई लेफ्ट. ये आपको प्रॉब्लम सॉल्व करने के लिए this is the basic formula. In the next sessions we will discuss about some of the problems on this part. Okay, right? This is the cell potential of a cell, electrode potential and cell potential of a cell. Even though there is a small difference between cell potential and EMF. What is that difference? आप यहाँ पर देख सकते हैं वो difference क्या है. If plug key is not connected in this part, if plug key is not connected, zinc electrode have a tendency to undergo oxidation. तो ये oxidation का tendency है इसको. That means zinc undergo oxidation to give Zn2 plus 2 electron. This reaction we can called oxidation half cell reaction है ये. And copper have a tendency to undergo reduction. That is aqueous copper Cu plus 2 ion gains 2 electrons and Cu it get deposited. यहाँ पर zinc undergo oxidation. Zn2 plus ion, in this case zinc enter into the solution whereas Cu plus 2 get deposit on the solution. Cu plus 2 deposit on the solution. So this is about electrode potentials के बारे में हुआ है. सेल पोटेंशियल एंड EMF में डिफरेंस क्या है? ये जो टेंडेंसीज इन दोनों में जो डिफरेंस इन द tendencies of these two electrodes, the potential difference between two electrodes is called as cell potential when no current is flowing through the circuit. अगर यहाँ पर ये ज्यादा है, देखिए पोटेंशियल डिफरेंस बहुत इनिशियल केस हम कंसिडर किया तो यहाँ पर हाई टेंडेंसी, ये भी इसका भी टेंडेंसी, इन दोनों का डिफरेंस जो है, क्योंकि अभी करंट तो फ्लो नहीं हो रहा है. In this case, it is we can called cell potential of a cell, EMF of the cell. If plug is connected, electron flows through the circuit. When current is flowing through the circuit, in that case we can call it, that is cell potential of a cell. So these are the some of points of difference. What is meant by EMF? Potential difference develops between two electrodes when no current flows through the circuit is called as EMF. Whereas if current flows through the circuit, then it is we called as cell potential of a cell. And this EMF represents the maximum useful work obtained from the cell, whereas this cell potential does not correspond to the maximum useful. And this EMF is measured by using potentiometer, whereas cell potential is measured by using voltmeter. These are the few points of difference. This is about electrode potential of a cell, electrode potential, and about cell potential of a cell. In the next video, in the next class, we will discuss about working of a DNL cell when external opposite potential is applied.